Okay. So in our last class, I think we have seen Docker, if you all remember, right? Think, yeah, this image is better. Okay. So what do you see on screen? A man trying to fix boxes, and someone is a driver of that trolley is having a coffee, right? Do you see that?
Yes, sir.
Just this one. Okay. What you see over here in the form of boxes are nothing but Docker images. Okay. This man who is trying to arrange these boxes is the Docker hub. Okay. And the guy sitting here having a coffee, waiting for this man to finish his job so that he can take this trolley to the destination is the Kubernetes. Okay. In a simple terms. So just be reminded of that image so that you'll understand things better. So far in the last class, what we have seen is traditionally people were trying to get rid of multiple hardware copies. They ended up virtualizing the machines and save the cost of the environment. But sharing has become a problem. So they created the virtualization of the utility and app layer by keeping kernel OS and hardware separate. Okay. Now, now we have so many Docker images which we start sharing among each other and eventually managing the testing development. But who will ensure that this is the right Docker image? This is the third version of the Docker image. Which version of the Docker image I need to pick? Which is the test ready Docker image? Which is the deployment ready Docker image? Or container image? I should say not Docker. I should say container. Which is the right container image is something very difficult for Docker itself to manage. Yeah. So something difficult for conventional Docker itself to manage because Docker and Docker engine are only responsible for image creation. Daemon will ensure that it generates the right image and registers in the registry. Okay, and eventually that image is sent to the target, and eventually he can work on it. But who will maintain the health of this container? Who will take care of the security of this container? Who will take care of deletion or updation of this container? Because this container is actually stateless. Okay, because it is stateless primarily because it is independent from the hardware and it is controlled only with the software component inside them. Okay, for example, if the Docker image, if you remember, if there is one developer who wrote a calculator program and created a Docker image where it has a calculator Python program, and that's it, calculator Python program, and he has a system utility of Linux. Okay, now he shared this Docker image to his friend. He's trying to open the Docker image using Docker desktop and tries to run the Python program this fellow has written. Okay, this fellow has written. But who takes care of the security? How does this person to know this is the right image sent by his friend? How does the person to know that this is the correct version of py file? Because person 1 might have created p1.py file, 2.py file, 3.3y file, and might have given instruction or missed instructions on which file to run. This guy might be running 2.py file rather running 3.py file. Okay. So all these challenges exist when people started creating too many Docker images. Okay, so um, that's where the tools called orchestration tools come into picture. Okay, orchestration tools help coordination among developers to tell which is the right image, which is the latest image, which is the old image. It's like version control for your images. Okay, and it also help developers like developer one to automate delivery of images. Like for example, let's give name to this guy. Let's the name of this guy is Sai. Number two is Raghu. Okay. Sai wants to share his Docker image which has calc program which can do addition, subtraction, multiplication to Raghu. But Sai sits in India, Raghu sits in US. By the time Sai wakes up, Raghu goes to sleep. By the time Raghu wakes up, Sai goes to sleep. So they can't literally talk to each other on demand to tell, hey, this is the right image. This is the right calc file you have to use. So what Sai will do is Sai will write one small bash script and he will tell, once I compile this Docker image, take that Docker file, Docker image file as input and move it to a folder called final. Okay. Now, whenever Raghu logs in the morning, Sai will go to sleep. Raghu will look at the files present in final folder. If the files exist in final folder, Raghu assumes that Sai has given him the file in the final folder. That's the correct version. Okay. So that type of automations you can do. That's how typically intercontinental dev teams, cross-continent dev teams, what they do is the person who works on the code during his time hours pushes his files into a remote repository. The person from other continent picks that files so that he can continue the code which is written by someone in other continent. Okay. All those things are taken care by tools like orchestrators. Okay.
Uh,
One good, sorry.
Hello, sir.
Yeah.
Sir, I was asking, sir, this version control of images is already done by Docker Hub and Docker Registry.
Yes. Yes.
So why do we need
I'm coming
like
there. I'm coming there. I'm coming there. Okay. So yeah, good question. So when you look at Docker Hub and orchestration, Docker Hub, when Docker was Hub was not there, orchestration was present. Okay. Orchestration tools like Kubernetes, which you see today, are something which have almost similar features like containerization and also orchestration. Okay. But traditionally, if you look, when there was no Docker, when there were only container tools, orchestration tools were present. Okay. So that's why I'm not giving Kubernetes as a base example for orchestration, a Docker for base example for containerization. Okay. Containers and orchestrators existed independently. When Docker came into picture, Docker observed that I can do better job in version controlling the image. So it extended the scope of container and became sophisticated tool. That's why everybody is using it. Rather than using container, the old tools, in-house tools, they started using it. Now, before Docker created something called Docker Hub, there are orchestration tools which were doing orchestration, managing VMs, managing virtualized environments, managing images. And by the time Docker Hub was introduced, Kubernetes came into picture. When Kubernetes told Docker that, hey, you can create image, but you can't manage them properly, I will help you in managing. So I will use the features of orchestration to do your Docker management. Now Docker said, hey, I don't need you, Kubernetes. I have created something called Docker Swarm. Okay. So Docker said, I'll create something called Docker Swarm. Docker Swarm is also a minor way of orchestration. It can't do complex orchestration. It can do smaller orchestration. Okay. So if you look at the timeline, people were using containers. People were using orchestrators. There were no branded tools. All are in-house tools. They have written their own tools. Okay. By the time Docker came into picture and became famous, why it became famous? You have to create your own images in the past. You have to create your own VMs in the past. Now, Docker's architecture helps you do it, so it is saving you time. So, people stopped using their in-house tools and started using Docker. By the time Docker came into picture, the in-house orchestrators tools, which were managing old container technology, also started using managing Dockers. Okay, but they are not robust because they are all in-house. They are not compatible with Docker architecture. So what happened? The people figured out a gap, and Kubernetes was developed. Okay, so Kubernetes was developed in parallel to when Docker was creating Docker Hub and Docker Engine. Okay. By the time Kubernetes is telling Docker that, hey, I am here to manage all your images, I'll take care of automated orchestration. Docker said, I don't need you. I have what we call Docker Swarm. Okay, this is the timeline. Okay, so what we see today in 2025 is where we are here today. We have Docker Swarm, which we have Kubernetes, which almost do the same thing. But if you date back to the 20 years ago, you have independent containers in-house, independent orchestras in-house. Today we have almost similar tools which will do both the job. Okay. So did I answer your question?
Like it is because of the timeline. Like
Correct, correct, obviously. Because you are exposed to both of these tools in 2025, uh, you don't know what happened in the past. That is okay. But if you speak to a 20-year-old developer who was using in-house container orchestration, everything was from scratch. Okay. So that's the idea. So if you carefully observe, what does orchestration do? Docker will create images. Orchestration tells you that I have bunch of images now. So once again, when I talk about orchestration, I'm not talking about Kubernetes as of now. Orchestration like 20 years ago. Okay. Just to understand the concept. Because before you run, you need to walk. So you need to understand orchestrators before you understand Kubernetes. Okay. So what orchestration does is, I have all the VMs, I have all images which are containers. Okay. Now get reminded of this image. Okay. This guy is the container, and these are all container images, and this guy orchestrator. Container management software will create containers. Orchestrator will collect those objects and take to and pushes them to the required destination. Okay. Similarly, if you go back, you have all bunch of images. Orchestrators tells you that, hey, I am here to manage your stateless images. Okay. I can define a workflow. What is a workflow? So for example, Sai created a calci.py file in one image, and it has to reach Raghu. Okay. 20 years ago, Sai has to write a bash script to tell that calci py file from 9 a.m. to 9 p.m. Sai made 1000 edits to this file. And Sai will tell, my last edit or last commit will be the final file. So, hey, bash.sh file, you pick that file, throw it in final folder so that Raghu can pick it up. All these steps, Sai used to write manually in bash. Okay. And using version control like Gerrit, bash will go to the logs of Gerrit and it will check where is the last commit, and it will eventually pick that last commit version file, reads that file, read file name, and MV moves that files to final folder. When Raghu logs in, Raghu do cd.final, and if there is a calc.py file, that is the file he will pick it up. This is 20 years ago how people used to manage their image sharing. Okay. Now what orchestrator does is, orchestrators tell you, don't write a custom bash script to read your version control system like Gerrit or Git. You follow workflow management in orchestration. I will tell you where is, so you only need to tell where is the source, where is the target. I will define the path. Okay, that is the job of orchestrator. Now, who will write a path? There will be a GUI. It will help you to design the path. So some people, for example, you have three development teams who is writing web, who is writing API layer or middleware, and someone is writing DB. All these people check into their version control or their Git. Okay. Using Orchestrator, I can define a workflow in such a way that all check-ins at before all check-ins by 5 p.m. Jan 10th will be used to create the build alpha. So people who are here working on all these code will try to commit before 5 p.m. On 5 p.m., the orchestrator will automatically finds the committed files, generates a build, and keep that build ready for deployment. So when the build is ready in the workflow management, once the build is ready, you can automatically create a stage image by creating a container. You can use container tool or Podman. These are old tools. Okay, these are not Docker. And they create a stage snapshot, they create a prod snapshot, and they give this to QA team. If QA team signs off, everything is good, then the updated test case image will be replaced on prod. So if you look at the workflow, this is step 1, this is step 2, this is step 3, step 4, step 5, step 6, which used to be done manually can now be done using orchestrator tool. Okay, so this is how typical old generation orchestrator tools work. Another example, if there is a large software product company, like let's take Workday. I don't know if you know that company, Workday or Salesforce. Okay, they have different products. I think I'll give better example. Let's give Zoho. Okay, Zoho has Zoho Expense. Zoho has Zoho Books, accounting software, etc. etc. When Zoho releases the product, they don't release Express 1.1, Express 1.2, Books 1.1, accounting software 1.1. They don't release like that. They will release it like a suite. It is called suite release. Okay. Suite 1.1, suite 1.2. So if you open suite, you will find Express, you will find Books, you will find accounting software, you will find invoice generation, inventory management softwares, all these things in Zoho. Okay. Now, when you use Orchestrator to release a suite, your life becomes easy because you have an expense management team who creates a build. You have a books team who creates a build. You have an accounting team who creates a build. You have an inventory management team who creates a build. All this code will be captured at one particular snapshot time, and a build gets generated. A container image of stage is created for QA team. And then once the QA is passed, if the QA fails, this failed stage snapshot is sent back to all the development teams to figure out the bugs. They will fix those bugs and they will send back the changes back to the staging in container. And from the staging container, if again the QA says it is good, it creates a prod container. Now all these steps, like step 1, step 2, step 3, sending back step 4, then again QA step 5, step 6 of prod template creation. All of these can be automatically done using orchestration. Okay. So in olden days, there used to be a DevOps team who used to develop in-house orchestrators. They never used to use third party. Okay. Even if you look at GitLab or GitHub today, they are open source and everybody uses it today. In the olden days, people don't used to use open source repositories. They used to use internal in-house repositories. They used to call as SVN, source code version network. Okay, they used to create own SVNs. From own SVNs, they went to Gerrit and open source Bitbucket or GitHub. From old age in-house orchestration tools, they went to uh, freely available tools called Kubernetes. Okay. Okay.
Sir,
Yeah.
uh, sir, like, uh, like this Kubernetes is sounding just like Jenkins. So, is there any difference? Because I have not, like, I don't know because I have not done any work on
Very,
Kubernetes.
very nice question. Okay. What Jenkins does is it will only help you do the build management. Okay. It will not help you manage containers, define the states of it, keep it turn on, turn off, security management, all those things Jenkins will not do. It will do build generation, build management, version management of the builds,
Like,
merging of the builds, conflicts checks. But if you look at Kubernetes, there are other features which I'm going to talk about.
okay, okay,
Okay.
like this.
So when there was no Kubernetes, when people couldn't afford own orchestrators, people lived on Jenkins to just do build generation and manage containers manually. Okay. So someone used to make a note that, hey, the container created on 12th January is the latest one. Okay. So that was the way they used to do the bookkeeping. It's not very structured. What happens if that guy is fired from the company? No one will eventually know which image had the right Jenkins build deployed and which is QA'd. So that was a state. That was a state in olden days. Because there were those problems, because they were not able to manage created containers, because they are not able to segregate the containers, because they are not able to define who should have access to which container, people started using orchestrators. Okay. But because everybody cannot afford writing their own orchestrators, they started relying on Kubernetes. Okay. Which is like an open, not an open source, it is freely available. Not freely, it is an product available for you to do orchestration. Instead writing your own orchestration, you can use Kubernetes. It's like if you want to do if you want to write a calculator program, you can write a calc.py file and do addition, subtraction, multiplication and division. But do you write your own calc file or calc Python file or buy a calculator? You typically buy a calculator, right? Rather writing your own calc.py file and open it and do the computation every time, you buy a physical calculator. Similarly, because people can't afford creating their own orchestrator from scratch, they bought Kubernetes. Okay. Now, any questions before we go it? Okay. So, in comparison to Kubernetes, there are other tools which also do what Kubernetes does, which also do what containers does in some form. Okay. What are they? One example is Jenkins. Okay. Which will help you typically do build generation, but will not manage the containers, or which cannot manage security for containers. If you remember, we spoke about Ansible, okay, in few classes before. Ansible is also like a container management software and orchestrator, but it is not compatible for large builds. I mean, if you have 50 builds, you have to merge them and create one image. It is not flexible to manage such a large builds. I mean, it's not designed for that. It is only designed for small human readable code, which is like one or two build, which you can generate and create containers. You can do that. Okay. Then another tool which is widely used in the world is Terraform, which even I used. So Terraform is like a infrastructure as service kind of an offering, which will give high availability of infrastructure, where you can do orchestration and provision infrastructure. Okay. And as I was telling before, in competition to Kubernetes, because everybody started using Docker, and to manage Docker, they started using Kubernetes. Docker thought, why I have to give my market to Kubernetes? And they created what we call Docker Swarm. Okay. Docker Swarm is like a Kubernetes, but it manages maximum 10 to 30 builds. It's not capable of handling 50 to 500 builds. Okay, it's not designed to accustom so many builds at a small time. Okay, so there are other tools also which are not widely used, but in this class we will only primarily look at Kubernetes. Okay, so I made all the required documentation available in the Git notes. You can actually have a look at it and read, but I'll try to cover, because we have to leave by 9:10. I'll try to cover the architecture of Kubernetes to show what exactly Kubernetes does to do the container management and orchestration. Okay. So like you remember, you have Docker engine. In the Docker engine you have Docker client, and you have Docker daemon, both interact with REST API, and then you have Docker registry, and you have link to Docker hub. This was your Docker architecture. Okay, now if you look at Kubernetes plays the game on what we called node. Okay, inside node it has something called pod. Okay, so each node manages too many pods. Inside every pod you have this container, Docker container here. I mean, let's not call it Docker, let's call it container. Okay, because you can use Podman or any other container tool, right? Okay, so node is the place which actually holds the containers in each pod. Okay, now if you look at, someone has to manage these containers, right? So there is a, like how you have a Docker daemon in case of Docker container creation, in Kubernetes you have a API service which is called kube API service. Okay, to manage this kube API service you have a storage called etcd. Okay, so etcd is nothing but a storage of which node contains which pod contains which or container file. All that info is sitting in etcd. Okay, and which pod should be made active, which pod should be made inactive, that is done by this Kubernetes API service. Okay, now there is something called Kubernetes scheduler. Kubernetes scheduler is used to define workflows. Okay, if you remember, I told in the previous slide, you will have an ability to manage when to generate build, when to create stage image, when to create prod image. That settings you can define. So that management will be done using Kubernetes scheduler. Okay, now there should be a control unit or a control manager. Okay, so that control manager actually manages the schedule and API events. Okay, this is called Kubernetes control management, controller management. Okay, now let us look at how this will impact. Okay, so there is something called kubectl. Okay, this is a service which will kick the Kubernetes. When you kick the Kubernetes, Kubernetes will create a node, it will create a pod, and Kubernetes will be linked with all Docker image repository. The control management of the Kubernetes will kick the Kubernetes API to read the images and dump it in the respective pods. So kubectl will tell kube API, kube API will ask Kubernetes control management what I need to do. Control management will tell go create the nodes. go create the pods inside them, go to the image repository, read the images, and place them in the pods. Okay. Now, all the states of the pods is managed by control unit. So you can define the scheduler, how long this, imagine this is a stage container, is a prod container. Okay. And there is a layer called load balancer, and there are end users. Okay. So now the QA team wants to access the uh, stage tested environment. Okay. So this guy will access Kubernetes, ask for stage container. Then Kubernetes will call the respective node, it will call respective pod, and it will open the container and gives it to the QA guy. If 10 more people ask it, it will clone it and create another container and give it to respective people. Okay. So basically, if you look at all the architecture again, in the centralized setup, you have nodes. Okay. Each node has a pod. Pod is the place where it will hold the container. You have a load balancer and end users here. Here you have the control management, scheduler, and API service. All the metadata is stored in ECTL, and the kube ECTL is the kickoff event which will tell API service what to do, and eventually the containers are rendered to end users. Okay. Now in the control management, if you go inside, control manager management has security engine, and it has another engine called lifesaver. Sorry, one second, let me check what is that. Life sensing. Second. Okay, I think it is called life sensing or health sensing. Health sensing module. And there is another module called configuration management. Okay. Security management will tell which user group has access to which container images. Okay. So people will do vulnerability testing, DDoS attack testing using the security management. The life sensing module or health sensing module will always sense whether the container image is up or down, up or down. So if you can define a configuration here that if the CPU consumption is hitting 90%, you bring that image offline. You can write those rule sets in the health sensing module. If the CPU utilization or RAM utilization is hitting more than 50%, add additional 10 GB RAM. You can write those rules in the health sensing module. And in the configuration module, all the workflow management, all the life sensing tasks, security management rules will be executed. Okay. So this is the primary role of configuration management of Kubernetes. Okay. Now what people do using this Kubernetes, people will, so what is the input to Kubernetes and what is output to Kubernetes? Input, all container images are managed, secured, health checked, configured, auto scale. Like I told you, right, in health sensing, if the benchmark hits 50%, it will add additional hardware. Similarly, auto scale vertically, horizontally, and then in the output, it will give the right container image to right people. Okay. This is the primary input and output goal of Kubernetes orchestrator. Okay. So this is what I wanted to cover in this class. If you have any questions, I can answer in next 3 minutes. Okay. Any questions? Okay, great. So as I said in the upcoming assignment, I'll not call it as an assignment. I'll actually call it like a hands-on activity. I in the Git book I made available steps to set up Docker, steps to set up Kubernetes. I'll give you some tasks to perform on those images. You can take your time in Teams. You create Docker images, use Kubernetes to configure and manage, and I'll give you certain tasks to complete. You complete them as like a team. I'll publish that group activity mostly by Friday. Okay, so that from next week you can start trying Docker and Kubernetes hands-on and see if you can set up and address the tasks which I'll eventually mention in the activity document. Okay, great. That's all I have to cover today. Do you have any questions? Any questions?
No, sir.
Okay, thank you, everybody. Bye.
Thank you, sir.